Everyone, and welcome to another episode of me just staying in my lab. I just realized right now that the electronics and video production is very synergistic because you need a lot of light for both. Anyway, today we have a Darlington gate. Focus, yeah, this is the Darlington gate circuit. I'll grab some paper to draw it. I'm back. This is the circuit. So this is basically the antenna, which is not actually antenna. It acts as one part of the capacitor and creates some parasitic capacitance. Wait, where's my pencil dirty? Create some parasitic capacitance with the wires. So the wires in the circuit are like this, parasitic capacitance. So this is the parasitic capacitance, and then you go to the base of this. And now transistors aren't just on and off. They change the resistance. If you put the higher voltage up to a limit, of course, it will lower its resistance. And you get like a little bit of voltage. And that basically just lowers its resistance just a tiny bit, so some current can pass, which will lower this resistance a bit more, allowing more current to pass, and lowering this resistance even more, allowing even more current to pass through the LED and opening it up. So basically, I will explain now on the real circuit. This transistor is, this one right here. You see them? Their bases, the emitter of one is connected to the base of another. Yep, in the middle. So this base, emitter base, emitter base, emitter base, until this is just ground. So this is here basically. And then this is the diode going through the diode, which is also connected to the collector of all of those, allowing for the amplification. And then to the base of the last one, you just connect the antenna, half a capacitor that we talked about earlier. So this is the circuit. My soldering is kind of sloppy. I 3D printed this also. But basically you just connect base, you have this, base to antenna, and then emitter, base, while putting the collector to positive voltage, and then the last emitter towards neutral, ground, and then a LED along the way. And yeah, now let's see it work. I have the power supply over here. You just need enough voltage for the resistor to open, which I'll put at 3.7 volts. Yeah, that seems about right. Oh, that disconnected. Wait. Yeah, you should. This came off. It wasn't the best solder job of my life. Okay, I have to redraw it in it. I'm not like the best at soldering, I think I said it earlier. I'm just okay, like my stuff is okay what I do. I don't think I picked the correct cable for this, because it's like a ultra thick cable. I should have just bought thinner cable from the hardware store. But all I need is a okay electrical connection. Okay, now I re-solder my iron. Never solder on paper like I did. Do what I say, not as I do. So yeah, now we're back. And I connect, this is the, as I told you, this is the positive. Basically, if you look at the circuit, this, the one in the middle, this, and the one in the middle, this here. So I just open up my power supply again. I connect this to the positive, then this to the negative. Right now it gained a pulse, but for you to truly see it, I have to close my lights. And now, so that is live. Now there's a bit, see, there's nothing in the LED. As I pull it closer towards that wire, lights up. LEDs are very weird on camera. Okay, let's give it a bit more contrast by upping the voltage. Here, it's a bit turned on. Now it's turned off. Here, turned on, turned on. So yeah, this could be considered an amplifier. You're basically amplifying the little current that you get onto it. So yeah, this is really nice. It's a like midday experiment, 10 minutes. I built this in like 10 minutes without the printing. So anyway, see ya. I will see you next time with another episode.